Namaskar. I'm Harpreet Kaur and I welcome you all to our live and interactive session. You're watching us on PM eVidya channel number 10. This session is meant for the students of class 10 and the subject that we have taken up today is sciences. Under subject sciences, we're going to learn about chapter number 11 of your textbook titled Electricity. So today we will be taking up part 2 of this session. That means in the previous session we have already covered some of the portion. We will give you a brief recap of the same as well. But for this session, of course, you can give us a call, you can write an email to us as well. In a short while from now, the session will also be uploaded on our YouTube handle NCERTOFFICIal. So, right now, since you're watching us on PM eVidya channel number 10, you can definitely watch us questions and get connected with us. Take down our phone number, that is 8800440559. Email ID is dth.class10@cit.nic.in. Now, to have a discussion on this session, we are joined by our expert. So, let's welcome him. We have with us Mr. Bergin G. Sir, namaskar and welcome to the session.
Good afternoon. I am Bergin.
Good afternoon,
In the last
sir.
session, electricity part 1, we discussed current, resistance, resistance in parallel, and resistance in series.
Right.
So, in this session,
of course, it's going to be a different session today, and let me tell you all that before, sir.
In this session, we are going to discuss about electric power, energy consumption due to electric power, calculate energy in kilowatt hour, and heating effect of electric current and its practical application in daily life.
All right.
So, let us start with the electric power.
Yes.
So if you take any electrical device like bulb, there are some technical specification written on the bulb device. So here also some specifications are here. I just zoom the specification. It is written as 220 to 240 volt. That means we are operating this bulb in 220 to 240 volt. Here we can use them in 50 and 60 hertz. That is, we can use the frequency 50 and 60 hertz. Another important term specification given here is 10 watts. This 10 watts represent the power of the bulb. What is really power means? Power, normally we are using energy by time. We are applying some energy for a particular time. That is, we call that as a power.
Okay. So
Here what is 10 watts means? The bulb uses 10 joules of electrical energy per second. That means if you supply 10 joules of energy per second continuously to the bulb glows continuously. That is the meaning of 10 watts.
Okay. And joules is the SI unit for energy, sir?
Yes.
Okay.
Joules is the SI unit of energy, and watt is the SI unit of power.
Right. So, you said that here power is mentioned in terms of energy and time. So, how do you calculate the power of an electrical device?
Yes. If you know the energy and time, we can calculate power. But it is difficult to find out the energy used in an electrical device. For that, what we can do is, I am considering a small circuit here. A bulb with a battery. The battery has 5 volt and some 2 ampere current is passed through this bulb.
Okay.
So, the current flowing through the circuit is charged by time. This we discussed in the last session. Similarly, voltage is work done by charge. That means the battery has some charge, and these charges, to move the charge, we have to do some external work.
Right.
That external work by charge is the potential difference that we call as a voltage. I just multiply these two, voltage and current. So, I write the voltage here work done by a charge and then charge in time. I can cancel this charge and this charge. So, we will get work done by time.
Okay.
The work done is nothing but energy is the work done. Energy by time, that we already know it is nothing but power. Therefore, power is equal to energy by time. The same can be written as voltage into current. So, instead of finding energy by time, we can find the power using the formula voltage and current.
Okay.
Voltage into current. If you know the voltage and current, we can find out power. Every circuit we can measure voltage and current. It is difficult to measure energy, but we can measure voltage and current, so we can easily find out power. this power is equal to, here the power is voltage into current, 5 volt and 2 ampere current is there, therefore 5 into 2, that is 10 watts. That is only they are given that the bulb has 10 watts power. If the bulb provides some 100 watts, that means the product of voltage and current is 100 watts. Not only this form, I used to P is equal to V into I. We can write in different form, because here if you know voltage and current, we can use this formula. Suppose current is not there. So by Ohm's law, I can write I is equal to V by R. If I multiply, I will get V square by R. So power is equal to V square by R. This is another form of P is equal to VI. Similarly, if current is there, voltage is not there, we can use Ohm's law, substitute the Ohm's law in V is equal to IR. So we will get I square R. So these are the different forms that whatever value we know, from that we can measure the power.
Okay. Sir, can you explain the electric power consumption of different devices?
Yes, yes. We are daily in our home, we are using different electrical devices.
Yes.
Let us discuss some of the powers that can be used. For normally we are using LED bulbs. LED bulbs provides 5 to 100 watts. If you take the LED bulb and see the that specification, you can see 20 watts, 30 watts, 40 watts, etc. Normally in our room, we can use only 20 watts. 20 watts is enough brightness. 20 watts bulb give enough brightness in the room. If you have large hall, we need around 100 watts bulb. So 5 to 100, normally 20 to 25 watts bulb is used in the room. But in the olden days, we are using the incandescent bulb. Before LED, we are using incandescent bulb. Now also in some places they are using. But the power rating is from 40 to 100 watts. Normally, if you want some brightness, we have to use some 60 watts. So incandescent, if incandescent bulb needs 60 watts, the LED bulb only needs some 20 watts. So in order to save energy, we have to use LED bulbs in our home. Similarly, the fan uses around 50 to 75 watts. Whenever we are going to buy a fan, we have to look at these things, because technical specification is more important while we are purchasing some devices. We are studying in the book, power is 50 watts, 75 watts, but in real life, we are not using that. Applying it, because if you they are only comparing the brand names, etc. But we have to compare this watts, because if you buy some devices with more power, then we have to pay more amount and we have a lot of energy to run that device. So that is very important. Some refrigerator, it is around 100 to 800 watts. So when you go and purchase one refrigerator, you have to look at the power. What is the power rate of particular refrigerator? If you have to compare and buy which is lower watts. So similarly, some AC which can be used is around 500 to 2000 watt. It consumes more power, more energy. It needs more energy to run. Similarly, washing machine will take 500 to 1500 watts. Desktop will take some 200 to 600 watts. Laptop, it takes only 30 to 100 watts. So our normal LED TV, it takes around 50 to 150 watts. The charger that we are using is 5 to 15 watts. And some microwave oven which has power 1200 to 2400 watts. And also the electric heater that we use has power some 1500 watts to 3000 watts. So in every electric devices, power is mentioned. So we have to look after the power and compare it, then we have to purchase it.
Well,
that we have to keep it in mind.
That is the
Yes.
entire, purpose of getting knowledge. Since you have explained it so nicely, what devices are consuming how much power, and of course that should be applied by going. Let's not just look at the brand, and we also see that they have some ratings also, like 5-star
Yes.
ratings. And what are those stars about?
Stars, if rating is high, then the power consumption is low.
Okay.
So we have to purchase by choosing a high ratings. Yes.
Higher
That is
rating.
yes, yes. higher
That is
rating.
important, because sometimes we also hear from these shopkeepers, a salesperson, that if you want to save your electricity bill, go for the higher ratings, go for the higher star ratings. And talking about electricity bill, when we look at the bill, we get units, for this
Yes,
much
yes.
of unit you'll be charged this much, for that much you'll be charged this much. So how is the commercial unit of electric energy, or I would say whatever devices we are using, is calculated?
Oh, till now we discuss about power. So power is not energy.
Yeah.
So commercially unit of electrical energy is we have to calculate, because
Right.
if you take a bulb with some 220 volt and 50 watts, that means the potential difference is 220 volt and power is 50 watts.
Right.
We are using the daily 6 p.m. to 10 p.m.
That's right.
This one bulb in a room. So we can calculate the commercial unit of electrical energy. Power has the formula energy by time that we already discussed. So from this, energy is equal to power into time, because power is the ability of the device, but if you want to run that device, we have to supply energy. If you look at the commercial unit, we have to look at the energy only, not power.
True.
So we cannot it is not able to measure the power and give the price. So we have to measure the energy and give the. So power into time will give the energy. So let us calculate the energy of this bulb. So here power is 50 watts. It is given as 50 watts, and we are using that time some 6 p.m. to 10 p.m. That is 4 hours. So daily we are using 4 hours, and electricity bill will come once in twice month. In our state it is like that. A different state has different problem. In Tamil Nadu it is they are calculating electricity bill in twice a month. So I take 30 plus 31 days as 61. If it is February, then it will be reduced. So normally you take 2 months, it will come around 61. If you multiply this term, you will get 12,200 watt hour. That means watt is the unit of power and hour is the unit of time I used here, because I am using 4 hours per day. So hour is the unit mentioned here. So watt hour. But if 1 kilowatt is 1000 watt. So if I divide this watt hour by 1000, I will get in terms of kilowatt hour. That is 12.2 kilowatt hour. This is the commercial unit of electricity. Normally we can say this as 12.2 units. So in our electricity bill, they are mentioning about 100 units, 200 units, 300 units, like that. So what is the meaning of, if it is 100 unit, that is the meaning is 100 kilowatt hour. That is the meaning of this. Suppose if you are using some 5 bulbs in your home, then daily you are using 6 p.m. to 10 p.m. Energy of one bulb is for 2 months is 12.2 units. If it is a 5 bulb, then it is into 5, it is some 61 units. So when you are using only 5 bulbs, each bulb with 4 hours daily, then for the 2 months the commercial unit is 61 unit. Like this, you can find out the unit or how much energy you used for any electrical devices. Okay. If you really love physics, you can measure the energy that can be used in your home, because you know what are the electrical things that you are using. How many, and then you can find out the power, time also. If you note down the time of use and you do one project and find out the total unit and compare this with the unit they measured. So if you
Yeah.
if it is come, that is the real learning.
We can calculate our own bill.
Yes, we can calculate our own bill, and we can argue with them also.
Yeah.
According to my studies, this is
Right.
coming.
That's
So
right.
what is the problem? So this kind of learning will really make the physics easy also.
Yes.
Make them.
And you can also relate it to real life applications, you know, real time
Yes, yes.
applications.
So
Yeah.
while we are using these kind of formulas, just you think about the real thing and apply the, within the formula. You can easily solve the problems which are asked in this area. The next topic in this session, there are two topics. One is power. What is power? And another one is effect of heating effect of electric current.
Yes.
Before discussing the heating effect of electric current, I just to tell one or two points on effect of electric currents.
Okay.
So when a current is passed through a coil, a magnetic field is created around the coil. That is called a magnetic effect of current.
Okay.
When a current is passed through some solutions, because of the chemical effect, there is some changes, and that type of effect is called a chemical effect. Plating, electroplating is done using this chemical effect only. Then another thing is when if using some devices, electric signals are injected into our bodies, and because of that some electrical signals are applied to the tissues, and we will study the changes, biological changes, physiological changes inside the body. That type of effect is called physiological effect. So similarly, if current is flows through the bulb, it produces light. So light effect. Current is produced through some speaker, it will converted into sound. So in the same way, when current is passed through some coil, it produces heat. That effect is called heating effect of electric current. In class 10 also, this heating effect only they are discussing. So there are so much kind of effect that when current is passed through something. So here we are going to discuss about this heating effect of electric current. So everyone see this kind of thing in your street.
Yeah.
So current is taken in Chennai, in cities, some cities current is taken under the ground, but most
Yeah.
of the places current is taken like this only. When current is taken like this, if current is passed through long time, heat is produced.
Okay.
We can't able to see it, but we can if you do the same thing with a battery and a wire, we can feel it. We can touch it and feel this. We can't able to touch it here,
Yeah.
but we can do the same thing in the laboratory and we can feel it.
Yes.
This heat can be utilized in different ways. For example, bulb, the incandescent bulb glow only because of this heating. Inside this tungsten filament is heated. That heated tungsten filament only emits light. So iron box, in the iron box, the coil, when current is passed through the coil gets heated. So and that heat is used for some the ironing the dresses. Similarly, toaster. The heat produced in toaster is used to toast breads.
Yeah.
So like that, this heating effect can be used in many ways. If the heating effect is large, for example, if some lightning is coming, so if some lightning is coming and it will produce heat, burn that whole thing. So if the heat produced is very large when current flowing, then there is a loss. But if it is controlled and we can use it in different way.
Right, sir.
So yes, in practical in our daily life, this effect of electric current is used in many ways.
True.
But you have to know how this heat is produced. So if you pass a current through a wire, inside the wire it looks like this. So electrons are moving and it will collide on the atoms. So whenever there is a collision, heat is produced. We know that.
Right.
So here also heat is produced, and this heat is only it is absorbed at the surface of the conductor.
Right,
So,
sir.
yes.
Now, sir,
So,
yeah, please,
uh,
because we have very little time left, just a few
same, okay,
seconds,
okay.
sir. So please explain it, and then we will wrap up.
Okay, okay. This is a small circuit. If you focus on the wire, if you focus on the wire, it looks like this. So power used here is voltage into current. We know that that can be written as V into I. Heat energy is power into time. So VIT, this is the heat energy developed in the wire. So VIT, if you substitute the value of V by Ohm's law, V equal to IR, it is IR into IT, that is I square RT. If
Yes.
voltage is given, we can write V square by R into T. So these three are called Joule's law of heating.
Right.
It is not three, but it is one VIT, voltage into current into time. That is the general formula. From that we can write I square RT or V square by R into T. So these are three forms we can, because the Joule conduct many experiment and find out the relationship between the heat energy and current, resistance, time.
Right.
So because of his name, it is called Joule's law of heating.
All right, sir. Thank you so much, sir, for this entire explanation. And because we're running short of time, I couldn't take further questions. But thank you so much for your contribution to the session.
Okay, okay. Thank you, ma'am. We
Thank
can
you.
see in another.
So that was our session on sciences, where we talked about electricity part 2, session taken by Mr. Bergin G, and of course he is PGT Physics from Government Boys Higher Secondary School, Salgudi, Tamil Nadu. With this, it's a wrap, but before I leave, here is an important announcement for all of you regarding the All India Children's Educational E-Content Competition. Well, last date is 31st of January 2025, and you can get more information about this competition from our CIET website, or you can scan the QR code on the screen. And now let's take a quick look at the schedule, what's all coming ahead. We are through with this session, and in a short while from now, you can watch our session on online training program from 4 to 5. 5 is the time for the session Sahyog, and at 5:30 we will bring you a session on school leadership and development. Thank you so much. This is me, Harpreet Kaur, signing off at the moment. Namaskar.